This is the brief on modeling heat diffusion from a point source using the delta function. So we're looking at how scientists use this really cool mathematical tool, the delta function. Think of it as a way to model super intense energy sources, like a tiny pinprick of heat. And this lets them create some incredibly powerful simulations of how that energy actually spreads out. First up, the core idea. The delta function basically acts as the perfect stand-in for a point source. So instead of thinking about heat spread over even a small area, this tool just says, nope, all the energy is right here, at one single infinitely tiny spot. And that kind of precision, it's absolutely crucial for getting the models right. Second, once we've nailed down where the heat is, the next big question is when. See, the system's behavior totally changes depending on its time profile. Is the heat on all the time, what we call a steady state, or is it just a quick blast, an unsteady or transient state? This timing difference is really the key to what happens next. And finally, these two time profiles, well, they lead to completely different outcomes. A continuous, steady-state source reaches a kind of balance or equilibrium. The temperature just stabilizes, depending on how far you are from the source. But an instantaneous pulse, that creates an unsteady state. The heat spreads out like a wave that has to, eventually, just fade away completely. So the temperature everywhere goes up, hits a peak, and then drops all the way back to zero. So, ultimately, if you want to predict the temperature, you've got to know, is your point source on all the time, or is it just a quick, one-time pulse?